want to do some stuff with equations here and truth sets. And suppose we started with something like that. It's going to say triangle equals 1 times box plus 3. And you have to tell me pairs of numbers, don't you, to know whether this is true or not. And the first number you tell me I'll put in the box, and the second number you tell me I'll put in the triangle. Okay, we always do it that way. And tell me a pair of numbers that would make that true, would you, Mary?
2 and 5.
2 and 5. She says 2 and 5, and let's see if that's right. 2 in the box, 5 in the triangle. Does it work? Hi, does it work?
Yes.
There's 5 equals 1 times 2 plus 3. Looks like it works. Tell me another pair that works. Look at it works, Nancy.
3 and 6.
3 and 6, is that right? 3 and 6? And tell me one more pair that works. Ann? Say it again, please.
3 and 7.
But it doesn't.
Oh, yes, and 4 and 7.
4 and 7. How about that? 4 and 7, does that work? Jim, does it work? Okay. I'll put that down. 4 and 7 works. Now, I'll tell you what I'd like you to do. Would somebody come and mark, here I have a table for my truth set, don't I? Now I want to make a graph to show this truth set. And let's make the graph over here. Somebody come and mark, in fact, I guess I won't do that, I'll make it on this one. Somebody come and mark one of these points. Let's see, we've got 2, 5. Somebody come mark 2, 5. Lynn, come mark 2, 5, please.
Which graph?
This one. How about it? Do you think it's right? Think it's right?
Yes.
Somebody come and mark 3, 6. David, come mark 3, 6. While he's coming down, somebody could be getting ready to mark 4, 7. Jim, come down and get ready to mark 4, 7. How about it? Is it right? Mark, is it right?
No.
Didn't give you a mark on it.
No.
Mark says it's not right. Neil?
Oh.
Which one isn't right? Chip, which one isn't right?
3, 6.
3, 6. Is that right? I'll check it. Let's see. 1, 2, 3. 1, 2, 3, 4, 5, 6. Right? Linda?
4, 7.
4, 7 you think isn't right? Come fix it. Piece of chalk. Okay, thank you. How about that? Do you think that's right?
Yeah.
I think it's right now. Okay, somebody pretend that you don't know about all this arithmetic and algebra and so on, but you've got good eyesight. You come and mark a point, and then after you mark the point, we'll do the arithmetic and algebra and see if you really did it right. Kathy, come try. What do you think? Do you think it's going to be right? I'll check up and see. See, what is it? 1, 2, 3, 4, 5. Is that right? 5. 1, 2, 3, 4, 5, 6, 7, 8. 5 and 8. How will I tell whether it's right or not? And what'll I do?
Well, you put the equation.
That's just what I'll do. Use the equation. 5, 8. True or false?
True.
It worked. Okay. Somebody pretend you forgot all about arithmetic and algebra, but you got good eyesight. Come and mark another point. Julie. You think that one's right?
Yep.
And what would I do to check it? Jim, what did I do?
Try it in the equation.
Try it in the equation here. Let me see. What is that? That's 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8, 9. 6 and 9. 6 in the box, 9 in the triangle. Did it work? True or false?
True.
Okay. Do one more without adding any lines or anything, and use only whole numbers, and mark another one. Brad? How about that? Do you think that works? Do one more, would you? One more still. Chip. And it's clear that that problem is too easy, huh? Okay. Thank you. Do you think that one works? I think it does too. That problem is too easy. That was the solid dot problem. Now I'm going to do another problem. And I'll mark this problem with X's. Okay, now we'll use X's to mark our points. And this problem is going to say, number in the triangle equals 2 times the number in the box plus 3. I'm going to say that. And let's get a point or two for a table here. Box and triangle. Mary?
6 in the box plus 15 in the triangle.
I'm afraid that's not going to fit on my graph. Can you use some smaller numbers?
3 in the box and 9 in the triangle.
All right. 3 in the box and 9 in the triangle. Does that work? Does that work, 3 and 9? Yes, it does. That's 2 times 3. 9. I guess that works. Somebody come and using an X this time, mark that 3 and a 9. Use an X this time. And? Okay. Thank you. How about it? Do you think it's in the right place?
Yep.
Should I check up? 1, 2, 3. 1, 2, 3, 4, 5, 6, 7, 8, 9. Looks like it is. Now, pretend you don't know all this arithmetic and algebra and stuff, but you're sort of shrewd. And you've got good eyesight. You come and mark an X where you think there'd be another point. Neil. Okay. Okay, thank you. How about it? Do you think that's shrewd? I think it's shrewd. Let's see if it works. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 4 and 10. It says 10. Put 10 there. 10 equals 2 times 4, 8, plus 3. True or false? It was shrewd, but it doesn't work. You suppose you could be even shrewder. This equation is somewhat different from the other one, isn't it? How is this one different from the other one? Somebody come and point to something in this equation that looks like it's different from the other one that we did, Lynn. Come point to something in this equation that's different from the other one.
It just goes there, there. But in this one, it would go there, there.
Well, point to the equation itself, not the graph, and show me something that's different. We had this equation one time. Now we've got this equation. What's different about the other one?
So that's 1 times box, and this is 2 times box.
How about that? Is that right? He says this was 1 times box, and this is 2 times box. And now that didn't work, huh? What do you suppose the effect of that 2 is going to be? Tom, come mark the next point with another point, would you, with a cross? How about that? Do you think that's shrewd? Let's see how it works. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 5 and 11. There's 11 equals 2 times 5, that's 10, plus 3. True or false? That didn't work either. Somebody want to come try something else? Mark, come try something else. You think you'd like it there? I'll erase the other one. And the one Mark just put down is right here. Let me count it. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 4 and 11. 4. The 11 is the same. So it's 11 equals 2 times 4, that's 8, plus 3. True or false? True. Right. Somebody who's got good eyesight but doesn't know too much about this algebra and so on, come and mark another X somewhere. Copy? How about it? Do you think that's going to work? Put up your hand if you think that'll work, would you? Would you put up your hand if you think that one's going to be true? All right, let me try it. I'll count it and see. 1, 2, 3, 4, 5. Is that right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Was that 5 and 13, was it? There's 5 there. 13 there. There's 13 equals 2 times 5, which is otherwise known as 10, plus 3. True or false? True. Somebody come and mark one more X on this problem. Chip, come mark one more X on this problem. Okay, Chip put it there, which is very shrewd if it works. Let's see. That's 1, 1, 2, 3, 4, 5. 1 and 5. 1 and 5. How about that? Says 5 equals 2 times 1, which is 2, plus 3. True or false? True. All right. Want to do one more X? That problem? One more X. Jimmy? How about that? Do you think it's right? Put up your hand if you think it's right. Maybe I don't even need to check that one. Is it really right? Won't bother checking it. Make another problem here. Make a problem down here. Different problem. I'm going to mark this time. We've used solid dots. We've used crosses. Now I'm going to use little circles like that. Okay? To mark this. And this is going to say the number in the triangle equals 3 times the number in the box plus 3. And we've got to start a table for that. Suppose I put 1 in the box. What would I put in the triangle to make it true, John? 6. 6. You agree? Is that right? 6. Somebody come mark that 1, 6, would you? Neil? Mark the 1, 6. Good, and that's a circle that he marked there. Okay, now somebody who's very shrewd but doesn't want to do any arithmetic on this, come and mark another circle where you think would be another point. And, you want to try it? Okay. And let's see how that worked. That was 1, 2. 1, 2, 3, 4, 5, 6, 7, 8, 9. There's 2 and 9. Is that right? 2 there and 9 here. How about it? True. That's true. What was different about this equation from the others that we had? Somebody come and point to what was different about this one. Nancy, come point to what was different about this one.
Well, the first one had 1 times box, and the second one had 2 times box, and this has 3 times box.
Yeah, she said the first one had 1 times box, this has 2 times box. One now has 3 times box. Somebody come mark with a circle another point that you think would work. Barbie. Okay. See, how about that? Think it's right? It's right. Should I check up or do you believe it? You believe it? Okay. I'm going to do something else. I'm going to mark a couple of points. I'll mark a point there, and I'll mark a point there. How many points will I have to mark? If this is going to be a straight line, how many points will I have to mark before you know where the straight line is? Mark. Two. That's what I think, too. So now you should know where the straight line is, and the equation for that is going to be something like, here's the x problem. It's going to say triangle equals something or other times box plus something or other. And the question is, what are those two something or others? Does anybody know? You know what either of those numbers are? Either. Neil.
The times, I think, is 1.
Times is 1. So I think that's right. Put up your hand if you think Neil is right. Okay, let's try that. We'll try that. We'll check up. After we get these numbers in, we can check up and see if it works. Huh? Now, how about the other number? What do you suppose it should be? Lynn, what do you think it is? 7. I'll think about that a minute myself. I don't think so, but I'll do it your way if you want me to. Let me try one other guess. Anybody else got a suggestion what the other number is? I don't think 7 will work, but I'll try it if you want. I'll try 7 if you want. Suppose I put 7 here. Now let's see. When I put 1 in the box, I'm supposed to get, if we're right, what should I get? I should get 1, 2, 3, 4, 5, 6, 7. Huh? So I put 1 in the box, and I should get 7 in the triangle. Did it work? No, I'm not at all sure that it did. I think that didn't work. Suppose I were to put a 0 in the box. What should I get in the triangle if this were going to work? What should I get? If this really were the right line, what should I get? Brad?
7.
Well, I don't think so. 0 and 7 would be 0, and 1, 2, 3, 4, 5, 6, 7. I don't think that's what I should get at all. What do you suppose I should get? We don't know whether that's right or not. That equation might be wrong. But what do you think, looking at the picture here, what do you think I should get if I put 0 in the box? Chip, what should I get?
The 0 in the box?
You should get the 7 on the line of the...
Well, 7 would be right there. Sort of peculiar. Mary?
You should get 6 on the dark line.
I think we should get 6 on that dark line there, huh? That'd look more like what I'd expect. If I put 0 in the box, I should get 1, 2, 3, 4, 5, 6. I should get that, but I don't. If I put 6 in, that's false. Somebody want to come and fix that up? Somebody come and fix that up. Brad, come fix that up. How about that? You think that'll do it? Try it. How many points do I need to check to be sure we're right? How many points do you suppose I need to check to be sure we're right? 2. If we check 2, that ought to do it, isn't that right? Because 2 points ought to tell us we've got the right straight line. I'm going to check this one because it's easy. That's 0 in the box, and 1, 2, 3, 4, 5, 6, 0 and 6. 0 in the box, 6 in the triangle. Is it true or false? That works, huh? And let's see. I'll check another one. I'll check this one off here. That's 1, 2 in the box, and 1, 2, 3, 4, 5, 6, 7, 8. 2 and 8. 2 in the box and 8 in the triangle. True or false? That works.